So here we have a function f which is made up of a set of few functions. So let's look at how theorem 2 and theorem 3 will be applicable. Let's look at this function first. It is a sum of an exponential function and a power function. So theorem 2 will help us reach a result over here. For this power function, we know that this one is going to be the big O of n square. Similarly, for this exponential function, we know that this is going to be the big O of 4 raised to power n. The question is, what about this entire function? How do we know what is the appropriate function such that we could say that 4 raised to power n plus n square is big O of a function g of n? What is that function g of n? That function g of n is going to be the max out of the two functions, 4 raised to power n, and the other function is n square. Now earlier we saw that for a positive d, any power function of this form n raised to power d is going to be the big O of the exponential function given by this form b raised to power n, where b is greater than 1. What this means is that exponential functions, they grow larger than power functions, and because there's a big O over here, so this is going to be the case that for some value of n greater than k, the power function the exponential function exceeds the power function. So therefore, out of these two, the max is going to be 4 raised to power n, the exponential function. So all this tells us is that this function is big O of 4 raised to power n. This one is big O of 4 raised to power n. If you have been able to follow the reasoning, then the similar situation happens over here. You have a power function and an exponential function summed together. We have n3, which is big O of n raised to power 3. Similarly, 15 raised to power n is big O of 15 raised to power n. Theorem 2 tells us that the sum of these two functions will be big O of the larger of these two functions. So therefore, this whole function is going to be the big O of the exponential function 15 raised to power n. Now finally, we can apply theorem 3, because now if you look at it, this is function f1 and this is function f2, and our function f is made up by the product of these two functions. We know that f1 is big O of 4 raised to power n, and we also know that f2 is big O of 15 raised to power n. Both of these results were obtained using theorem 2. Now theorem 3 tells us that because function f is the product of f1 and f2, this function is going to be the big O of the product of these two functions. So the result is 4n into 15n. This example completes the demonstration of both theorem 3 as well as theorem 2.